Good morning, everybody. This is Ercenk Keresteci. I'm hailing from the wonderful Pacific Northwest. I'm a solutions architect, and I'm working on the Azure team. I'm primarily focused on the manufacturing ISVs. I'm in Seattle, so I'm Seattle-based, closer to the kitchen in Redmond, and I've been working on complex solutions for quite some time now. So what we're going to talk about this morning is that we're not going to be talking about the apartments, but it's just like this resemblance for a complicated architecture and the way that you accommodate multiple people, multiple families is really interesting. So some of you guys may be living in single-family homes, and the typical situation in a single-family home is that you get to maintain your yard. You either pay for the service to get the yard maintained. You take care of your house, lots of maintenance work there, but you end up having your own privacy with your family. There's the other option, of course, in the condos. You have got apartments, and in the condo buildings, you have a maintenance crew. You're paying for it, and you're just the maintenance is much easier. So the resemblance of a really complicated SaaS solution is evident there, and you can also think about like how you can accommodate multiple different tenants in your SaaS solution, and how you can architect that solution in a scalable way and secure way so that you can accommodate those different customers. Um, I know that quite a few of you have been working in the software industry for a long time and have a lot of experience as well. So I really don't want to be stating most of the obvious things that you already know. So I'll try to focus on the commercial aspects of a solution, and starting from the fact that we are looking at architecting a solution for a software vendor with the goal of selling the solution to the customers. What are the important technical aspects we should look at from the commercial perspective? So I hope it's going to be a valuable session, and it's going to be your time will be well spent. I welcome your questions, and I'm always excited about seeing interesting questions. So challenge is a way of life for me. Feel free to post your questions on the online chat window, either throughout the session or during the Q&A period at the end. With that being said, um, I'm just going to go through multiple different points of views, like what's the SaaS, what are the service models, what are the building blocks, and I will end up with a key takeaway. I will even try to do a demo. We'll see how it works. And besides, this is one of those interesting times in our lives. So again, thank you so much for joining me online. I have presented this session at Ignites in multiple cases, multiple cities, and this is quite new for me as well to present an online audience without actually being in the same room with them. So thank you so much for being with me here. Let's first start with the definition. Software as a service, as a term, is oftenly used situation, but even though everybody uses the word or the acronym SaaS, it may mean different things. It may create different perspectives for different people. And if you just look it up, the wonderful resource called Wikipedia, and I know that some of the folks that Wikipedia is not the official resource, but because it is driving the consensus, I want to show it as an example. So in Wikipedia, the software as a service is defined as the software licensing and delivery model in which software is licensed on a subscription basis and is centrally hosted. I'd like to challenge this because is that what is central, and what is it really how you deploy or how you manage or monetize? So does that really matter? For instance, that my service is all about deploying components of my service to the customer's environments and then manage them remotely without customer actually touching them. So does that count as a service? I think it does. So it takes away the argument of the solution being centrally hosted, for instance. So um, I've I claim that software as a service in the software as a service model, the service boundary is not on the deployment boundary. So it's not dictating where you deploy and how you deploy, but the software as a service, the service uh, word is actually dictating how you're managing the solution on behalf of your customers, and also how you're monetizing the solution, which parts of the solution you're monetizing, and how you're doing it. And the aspects of a typical software as a service solution also is that it should give you the ability for self-service for the customers, and also accessing from multiple channels. That should also bring in the seamless billing. So these are kind of like sometimes ideas or sometimes points of views that some of the solutions I've seen in the past missing. Looking at the considerations for a SaaS solution, we can talk about the business considerations first. In that, how am I going to put together the business model for my SaaS solution? What's the strategy and financial model for my solution? How am I going to expand it in the future? As I expand it, how am I going to change the prices of the different levels potentially of the different SKUs I have? How am I going to hire and train talent operating my solution, and change my operations model as time goes on, because we're talking about a SaaS solution, and my implicit bias is, of course, towards a cloud solution, having worked on the Azure platform for many years. And as we always know that in the computing industry, in this world, the abstraction level is always getting higher and higher. I remember times when I, in fact, actually did program on the card computers. So I had to do the card punch card machines, and then compile my code on with the punch cards. And now we're talking about configuring software with YAML files for MCUs, and not even thinking about assembly models, so assembly programming. So as the abstraction layer gets higher, the skill set of your people needs to increase or change as well. So how are you going to approach that? And besides that, what is your strategy for go-to-market? What are your sales channels? How are you going to, as your sales channels change, how are you going to close the deals? What's going to be your sales model, etc.? So these are all interesting considerations that you should take. The next thing is the next point is the management consideration. So here, the application can be completely shared. The moving parts of the solution can be completely shared, or the instances. So one instance per customer can be your model, or your model can be, you can be actually deploying the customer instance of your solution to their Azure subscription and manage it on their Azure subscriptions. From the billing perspective, what are the billing and licensing considerations? How am I going to charge the customer? Is it going to be flat, monthly, yearly? Is it going to be per seat, per user, per device? Am I going to be having any other variable metering, usage-based metering considerations, such as is there a situation where I will need to charge the customer per the machine learning model I train per scenario they have? And if I do that, how am I going to meter or count the usage? And then how am I going to then generate the bills out of that? Am I thinking about bundling services, professional services into solution, or does my solution come with services and hardware? So those are all different billing and licensing considerations, because in certain situations, the hardware you bundle and may not be mixing well with your sales channel because of the regulation constraints. In other words, you may not be able to sell to a certain country through a certain channel just because of that target country's regulations are not really conducive for you to sell the hardware directly from your online business. So that also changes how you approach your SaaS solution. Looking at all of that complicated situation, there are certain helps that Microsoft comes up with. So there's this tool called SaaS Potential Calculator. What I usually use this tool with is that as we talk through the different business models, different deployment models, etc., and then once we identify the SKU, then I bring in this tool to land the SKUs on so that we can start talking about the dollar figures. But I'm going to make the slides available after the session, so you should be able to go and take a look at this resource. And it is not the smallest URL that we can probably remember. So you're going to find it on the slide deck once I share it. Okay, now let's look at the management models. As I mentioned before, everything can be shared. So this is the typical multi-tenant situation. Or there might be per customer solution assets, or there might be per customer deployment. And on top of that, there's the hybrid model. With the everything is shared situation, software provider, and again, let's just for all practical purposes let's assume that we are on the cloud and we are of course using Azure platform. In the everything is shared model, the management boundary is at the solutions Azure subscription. In other words, software provider has an Azure subscription and everything is deployed in that Azure subscription. So the shared solution assets can be things such as data stores, right? So if you just take a very simple example, you might have an Azure storage account and you might have different containers for each customer, and you might be uploading the data as they come in from those customers to their own containers. Because it's your solution that controls the access, nobody else but your solution is actually accessing that shared resource, and the customer does not really need to see where the data is stored. Another very typical example is with the relational databases, right? So in that relational database, you may have one single table. Let's say this is an assets management solution, and you might have one single assets table that has all of the customers, all assets in one single place, but you might be differentiating the different customers' assets by using a customer key, for instance. Or again, with the same example, you might have per customer tables, etc. But the idea is there, right? And the assets you deploy, let's say the database or database server or the storage account, etc., that is the one that's shared. Another example is a web application, for instance. So it's a single web app front end. Maybe you're just differentiating by the DNS subdomain, and you're utilizing you're utilizing services like web application gateway, and you're basically mapping all of the subdomains into the same deployment and serving from the same subdomain, saving from the same deployment, and you're using just host headers for showing your UI. The per customer solution asset is this is usually driven by regulatory compliance or privacy requirements, and sometimes also the performance requirements. So in this situation, the software provider, the management boundary is at the Azure subscription level, and in the Azure subscription level, the software provider may provide different solution assets per customer, such as database servers, for instance. And data is usually the place that's driven by the regulatory compliance and privacy requirements. The typical example is the GDPR situation, or another typical example is the solutions data storage area or the data location is dictated by the government regulations. And on top of that, the solution may also have shared solution assets. The third model is this is the per the customer deployment on customer Azure subscription. So in this case, the management boundary is again the solutions Azure subscription, but the customer maintains the Azure subscription all up, and the solution assets are deployed to the customer subscription. Here, there are two important technologies that come from Microsoft Azure. One is the Azure Managed Applications. The other is Azure Lighthouse. Azure Managed Applications allow you to package together a complex application in one single deployable unit. You can also expose it through Azure Marketplace. So you can monetize the solution through Azure Marketplace. Solution components will end up being deployed to the customer's Azure subscription. And then you can put Azure Lighthouse on top of that for managing multiple Azure subscriptions on a single glass. So that I would recommend you to take a look at Azure Lighthouse. Quite interesting and exciting solution there. And so we talked about three different deployment models, management models, and on top of that, we have the hybrid model. So in the hybrid model, you may have the solution assets running on your side as the solution provider, but also certain things are deployed on the customer subscription. Looking at all of those deployment models, management models, how am I going to architect for a SaaS service model? So this is where most of the common things or common aspects are coming in, and this is not specific for a commercial application per se, but the typical architecting approach for a highly available, scalable, and secure application comes into picture. Let's go through the cloud models first, and then go to the SaaS application reference architectures, and I will talk about the application building blocks that we can consider. If you look at the cloud deployment models, I've noticed that, so let's just jump back real quick here. So in the cloud models, we have wonderful four-letter acronyms like infrastructure as a service, platform as a service, containers as a service, and functions as a service. So this gives us quite a bit of flexibility on the resources that we utilize on the cloud side, and the level of management that we can get from the underlying platform changes by different deployment model. So in this example, this is coming from Microsoft's architecture center. So in this model, you can see that a hybrid approach with PaaS and function as a service models. So here you can see the solution is authenticating the users coming in from the internet using Azure Active Directory. It's also making DNS lookups for finding the IP address for the service, and then going through the Azure front door service, as well as utilizing Azure CDN for any static content the website is or the web application is utilizing. There's a web app service. There's an app service plan hosting that web app. And this is a scalable solution because it's using the typical queue processing model. So you may see it in different ways. So sometimes it's referred as Markov models. Sometimes it's single queue, multiple server models. But at the end, this is all about smoothing out the incoming demand. So on the other side of the queue, we have the function app, and this is accessing the underlying data stores. As I mentioned, these are available on the Architecture Center on the documentation side. So you can have a basic, so you can look at the blueprints for the basic model and an improved scalability model, a model with multi-region deployment and monitoring all of these SaaS applications. Let's look at the building blocks. What are the important parts that we should be considering? So I would like to group it into three different areas, three different blocks. So there are the operation blocks, there are the application blocks, and the DevOps blocks. So on the operational blocks, let's just take a step back and look at the just a minute, please. Yeah, so on the SaaS building blocks, sorry about that. This is, I think, the typical disturbance that you'll see when you're working from home. And it's good that I don't have the visual, so you didn't see a tiny little kid crawling through the door and getting into my room. Kidding, of course, you probably saw that famous video. So going back to the presentation. So on the operational blocks, I'd like to focus on the parts that are important from the commercial aspect. So these may not necessarily 100% fall onto the regular way for deploying, managing a SaaS application, etc. But it's more kind of like, okay, I'm selling the solution. What are the things that I'd like to see? And I'd like to. So before I go to that highlighted parts, I'd like to focus on a few things, like metering part. So metering in this sense is that we're not talking about metering for usage and billing, but we're talking about metering for certain parts of the solution and then understand which parts or which feature sets are used more popularly. This is a very interesting situation that I've seen it over and over again as I work with many different ISVs, many different solutions. And also, I noticed that during my tenure with the Microsoft product teams, in every single situation with any given developers will have their most favorite technology or most favorite feature area, and then they think that that's the most important thing ever for the overall solution. The truth may not be the same. So once that solution is out in the market, you're going to see that some parts of the solutions you think that are really valuable and will be used are not really being used that much. And some of those side area, you're going to see, oh, everybody is using it. How are you going to determine that? So what I really recommend here is that make sure that you instrument the code right so that you can understand the usage patterns on your solution. Because the usage patterns will determine the areas for future investment. And if you notice that a certain feature area is being used more often, it may be actually your next business case. So it may be your next, the best application ever to make money from. So, so metering in that sense is different than basic logging and monitoring for diagnostic purposes. The other part is the tenant administration. How am I going to administer different tenants? What is my process, or what's my policy if a tenant moves? So tenant goes away. How am I going to retain the tenant? How am I going to make sure that the tenant can come back? What's the level of the data that I can keep and I can use? So interesting parts there, but I really don't have, unfortunately, enough time for this thing. So I'd like to, for talking through the rest of the points, but I'd like to highlight the four important aspects from the commercial point of view. Then you can see, of course, the other blocks or the other points under the DevOps blocks like continuous deployment, continuous development and deployment, continuous integration, etc. So those goes without saying. Those are important aspects for almost all of the solutions, but I'd like to focus on those 4 that I highlight just because of the fact that we don't have enough time, and I also would like to highlight them for the commercial aspects. Let's look at those 4. Let's start with the tenancy first. The first thing that you want with a SaaS solution, it's SaaS as a service, goes without saying. It comes with the boundary, or it comes with the situation that you are going to have multiple tenants. Those multiple tenants, you will need to. That means that you will need to service those tenants for the things like securing their data boundaries, or making sure that the resources are shared fairly, or in a way that they paid for. You'd also like to make sure that the scale and performance observed by the tenants are at the acceptable levels and agreed levels. Capacity is also another important part when you're looking at tenant boundaries. So here's an example. Let's assume that you are relying heavily on Azure storage service. Azure storage service does have some scalability and performance targets. Take a look at it, please. So there is a limit on the number of transactions you can have, right? So the number of transactions you can have on per storage account may dictate you to expand to multiple different storage accounts. So the capacity problem or the capacity limit on that transactions is going to change, is going to determine your approach for tenant boundaries. Also, the other thing is that, as you remember, I started off my presentation with the resemblance of a condo, right? So there are going to be noisy neighbors, and you should think about noisy neighbor problem, meaning that one tenant might be doing a lot of requests on your server and starving the others who are trying to get into. So the typical manifestation of it on the Azure platform is that you get throttled, right? So I believe it's 429. So once you do too many requests, you're going to get a throttling request, throttling response, and then you're expected to act accordingly. And also there's the cost trade-offs, right? So if I end up like, oh, I'm going to isolate all of my tenants and I'm going to put them on different database servers, etc., then it becomes more costly to manage all of those different servers. Again, just if you look at the partitioning schemes by service, because you are going to be deploying or you're going to be utilizing assets on the service, there are different schemes that you can see. Things like at the database level, probably at the table level or database level or server level. On the website of the things, maybe it's the custom domains, or maybe it's just a subdomain, or you're going to differentiate the customers with different URL paths. Things like you may provide branding support on the UI, or you may isolate the network traffic, or if you're deploying on a container service like Kubernetes, you may want to employ things like namespaces. And when you're thinking about, or when you're planning the tenant boundaries, you should also think about the operations part. So resize the customer. So how am I going to resize the customer deployment? If you have small, medium, large SKU plans, and if the customer wants to go from small to large, how am I going to resize this? What's going to be the business continuity plan for the tenants? Am I going to allow point-in-time recovery for customers, etc.? So this is point number 1, tenancy. The next is onboarding process. And I'd like to clarify a few, again, terminology here. I hear onboarding and provisioning used interchangeably, but I'd like to stay as consistent as possible here with what I mean. For me, and when I'm explaining the concepts to the teams I'm working with, onboarding is the process. So onboarding is bringing in a new customer, gathering additional information from the customer, and then orchestrate the um, uh, provisioning across different systems. Provisioning is separate steps that are contained within the onboarding process. So you're going to provision resources, you're going to provision identity, you're going to set up billing. So those are all different provisioning. When you look at the resource provisioning part, allocating the resources also brings in core considerations like, am I going to keep the resources and allocate the resources and keep them cold? Am I going to be warming them up? So the cache is populated, etc., and then customer can go right off the bat. How am I going to provision the resources? Is it going to be automatic, or is it going to be out of band? Meaning, like Joe is going to run some scripts and then click away some portal, some UI for provisioning a new customer. Also, be ready to scale up and down with the resources you provision. Going to the third one, identity. Identity, if you look at the options you have, you can roll your typical username, password database. You can use a B2B approach like Azure Active Directory. You can use consumer identity providers, many, and you can also think about the single sign-on. But when you're looking at it, consider the authorization part, right? The identity provider is going to take care of maintaining the identity and authenticating the user, but authorization is completely on the SaaS side. Think about, once you identify the user, what are the schemes, or how am I going to authorize and manage the authorization of different end users from the customer to access the solution. Do keep audit logs and also consider the self-service options, because you will be probably resource strapped for servicing the authorization modification demands, etc. SKU plan and design. So this is the last part, and this is one of the interesting and often overlooked parts. Here I propose a framework for approaching the SKU plan or SKU or plan design. Over so many years and with so many different ISVs I worked with, I noticed that there is not one single method for going through this. How am I going to differentiate my SKUs? How am I going to price my SKUs? Is it going to be the same architecture, different, etc.? So I ended up coming up with a framework here, a framework approach as opposed to a methodology approach. So in other words, I don't think that this is one single recipe that you can start from the top, given your requirements, and then it ends up with, okay, so here are your SKUs and here are the price points for those SKUs. I don't think that's possible. However, starting with a set of principles and approaches may help you in this journey, and look at so that it can help you to uncover areas that you may not be thinking before. So the way that I organize my framework is that so there's the management model. Management model dictates that how you deploy and who's going to deploy it and how you're going to operate it. So management model also determines the management complexity and administration costs. What's the skill set that I'm expecting from my operations people to operate this thing on the long run? The architecture model, on the other hand, it determines how the solution looks like, and it dictates the platform components, underlying platform components you're using, which is basically one of the most important components of your cost. So the cost of goods coming from the platform components is going to be the major driver for your pricing strategy. And then the feature composition, exposing different features, combinations of different features to your customers, will bring in some engineering costs, because the level of the feature and the complexity of the feature is going to determine the skill set you will require on your team to build those features. And the richer the feature set and the more complicated the feature set, goes without saying, is the personnel cost. So how do I approach it with a framework? The way that I do this is that first I look at the deployment classes. So deployment classes those are going to be telling me that what are the different sizes, or what are the different types of deployment models I will need to consider, given the fact that I'm exposing the solution to multiple customers. So starting with the functional and non-functional requirements, it will give me the high-level architecture. Starting from the potential system components that I will need to use, such as at the high level, I'm going to expose a UI through multiple different channels, including mobile, and it's going to go and touch a data store, means that I will need to think about scalability, because if you think about mobile, then that means there are going to be lots of customers using this, or customer users using this. The t-shirt sizing for customers will also determine the different types or different classes you can use. This will lead into the feature combinations. What are the different feature combinations I'd like to put together? So does that make sense to provide different feature groups and organize them into different SKUs, etc.? So these two will help you to determine the price of the SKUs, because let's move on to this one, right? So because functional requirements and non-functional requirements will determine, or will point a high-level architecture. That high-level architecture will come, let's say, with the previous example, we had a mobile solution. We have a solution that's available through mobile and also web. So that will determine where am I going to deploy the solutions moving parts to. And if this is a scalable solution, then that means that I will need to use message passing solution. So a message passing solution on Azure means Azure storage queues, of a highly scalable hosting platform for your code, may mean Kubernetes, Azure Kubernetes service, so on and so forth. Also do the customer t-shirt sizing. Customer t-shirt sizing will be dictating the potential footprints of your deployment alternatives. So you can be putting these things on different sizes of the clusters, etc., and then you end up using different VM sizes, so on and so forth. And then the feature combinations start with what's needed for the customer, and then what features make sense to be put together. So you can have a set of groups for different features, different feature combinations. All of these, starting with the deployment options plus the feature combinations, are going to be helping you to come up with the SKUs with the costs. Because if you remember, going back to, and I hate to do this, but I will do this. So I'll jump back a few slides and look at this. Management model is going to determine the management complexity, thus the administration costs. The architecture model is going to show you the platform components, thus the cost of goods. And then the feature composition is going to be determining the and tie the feature composition and the feature usage with the metering concept I mentioned before. In other words, instrumenting the code so that you can see which feature is more popular, so that you can go towards where people are voting with their feet. So that will determine your development costs. So all of these are going to be deployment options, and feature combinations will be showing you the SKU picture together with costs. Then you can bring in that tool that I mentioned at the beginning to lay that SKU, put that SKU, and then now you can talk about the dollar amounts, because now you understand the costs, and now you can start thinking about your margins. The last one is the billing part. So the billing service, external billing service. So Azure Marketplace is a great alternative. Azure Marketplace SaaS offers are actually quite interesting. It is very flexible. Given the options and given the primitives we have out of Azure Marketplace for SaaS offers, you could come up with some very interesting billing models that really works for you in your situation, in your unique case. I will skip the demo part because I want to focus on the key takeaways. I really didn't want to make this Azure Marketplace talk. So I really wanted to focus on the architecture aspect, so that's why I'm skipping that. But do please ping me on LinkedIn if you're interested in understanding how Azure Marketplace may be helpful for your case. And I will be more than happy to help you navigate through the various different options on Azure Marketplace. So first of all, provisioning for a customer is a trade-off between cost, security, capacity, performance, not on one single aspect. When you're designing your SKUs, including the cost of goods, value delivered, and approach methodically. So try to use a framework. It doesn't have to be the framework that I presented here, but think methodically and then look at the different areas and then just make sure that you don't miss any part. And also when you're putting together a commercial SaaS solution, there's probably somebody else who has done a fairly good job for addressing a certain part of the solution. Focus on your business problem. Focus on the problem you're trying to solve. Let's say if you're in IoT analytics area for manufacturing, look at the manufacturing problem, but don't try to solve the best, identity provider problem. There's an identity provider solution somewhere that you can use as a component, or don't try to solve the billing problem. There's probably a billing solution somewhere out there, like Azure Marketplace, and go and use that. So with that, there is a set of resources on the deck that I will share, so that you can go and see what are the available resources on the Microsoft side for different cloud models, and also some links for a few topics here. You can also see the SaaS playbook and potential calculator tool here. That being said, my part is over. I'm going to hand it over to our wonderful team, and I will start the Q&A session. I'm sharing my screen.
Thank you so much. That was great. I just want to tell you about some of the other events coming up from the Microsoft industry team that we have. Our next one is going to be June 30th from 9 to 10 a.m. Pacific Standard Time. And this is enabling SaaS applications for the commercial marketplace. And again, this is Pacific Standard Time. You can register for all of these events on our Microsoft Meetup pages. I have the link for our Redmond one below. However, some of you may be members from San Francisco or Toronto, New York, and you can register for any of these events on our Microsoft Reactor Meetup pages. If you want to join the community or hear about other events we have coming through the reactors right now, these are all online, and again, you can find them on our Meetup pages.
Okay, wonderful. So let me go through the questions that I received here. So first question is, are there any tools to help build these models on Azure that take into account tenant management with resource management? I wish I could have a very simple answer here and say, yes, here's the tool. But given the complexity of the situation and the complexity of the SaaS solutions, there are many tools that you can take advantage of. But they are not necessarily targeting building SaaS applications. And the other thing that I note, I experienced every single time I say so many different years. I think it's just like I think like I'm revealing my age, which is not a great thing, But the reality is that the teams culture and then team's experience also determine the tool use. So for some teams, a given tool might be the best tool ever, but for the other team it may not be. So I'd say use as many flexible tools as possible in a way that fits to your needs. But going back to your question, direct answer to it is no, there is not one single tool building those. The other question is, so this approach for building SaaS seems really similar to Jovi and X solution. Do we officially support it? I don't know that solution. And so everything I presented is coming from my personal experience together with our collective experience that we as Microsoft put together over the years. We don't, as far as I know, we don't officially support it. I don't know Jovi and X solution. But I will be more than happy to learn. So feel free to reach me on LinkedIn and let's chat. That being said, these are only the 2 questions. We still have 9 minutes left. Please feel free to ask more.
Again, does anyone have any questions at this time in regards to the presentation?
Okay, we have a question here, which is, what would be key consideration to migrate an existing mid-size application into SaaS platform?
So I'm assuming that is a single tenant solution. The first thing that you will need to think about is that how you're going to, if you're going to be using multiple different tenants, of course, goes without saying. How are you going to approach the tenant boundaries? What are you going to be deploying separate instances for each tenant, or are you going to be using using the resources, reusing the resources? And by the way, my bandwidth is not going good, so my connection to live event service is not going well. I cannot see your questions, so the team is helping me out with the questions. So thank you so much. And if you notice that I'm a little bit hesitant because I cannot really read your questions anymore. And
well, we do have another question
here.
here.
I'm sorry. Yeah, go ahead, please.
We do have another question here, is how can we identify if a product is best sold as SaaS?
Okay, interesting. So that's more kind of like, I see it as, and if I understood the question correctly, is that do I need to make the solution SaaS? It goes back to the original situation, right? So the original, my original premise at the beginning, that what's a SaaS? So if you're expecting to manage the deployment of solution to a customer situation or per customer, then that is a SaaS solution, right? So because that's the requirement. If the customer is telling you that I really don't want to, I really don't care about where I deploy this, how do I, set up the VPN, etc., or the VNet for the different, components of the solution. Go and do this for me. All I need is to run a bunch of simulation software packages. Then that actually tells you that there's a need for a service. And the word service in SaaS also dictates that it is a demand coming from the customer to make some of the things, some of the aspects easier for the customer. So that's how I would see a solution as a SaaS or not. And I was going to say that if you have any questions, again, please do reach me out on LinkedIn. There are not that many Ercenk strategies on LinkedIn, so you should be able to see it, find me quite easily.
Okay, thank you so much for joining us today. Again, if you have the opportunity to submit our survey with event code 7683, that would be really helpful for the Reactor to continue providing events and sessions that work with the community and things that you want to hear. So definitely submit that survey. We're gonna wrap it up now. If you have any other questions, do feel free to reach out to the Reactor. Thank you very much.
Thank you.